In this video, we'll discuss triangle congruence. Now let's first talk about the idea of congruence. This is when two shapes or solids have the same size and shape. We say that they are the same size and shape when their angle and side measures are equal to one another. This is created using the translation, reflection, and rotation methods of transformations because those three methods will change the position and location but not change the actual shape. Now, two key important pieces of congruence. First, we cannot assume congruence unless measurements are provided, corresponding parts are marked, or there's an explicit statement telling us the shapes are congruent. Otherwise, do not make that assumption. Second, when we want to name one shape as congruent to the other, we're going to use the matching corresponding vertices. That will help us know how the shapes are congruent as well as being congruent. So let's look at these two triangles and say, are they congruent? Well, they look congruent. They look like they have right angles, but nothing is marked, nothing is measured, nothing is stated. Because I have no information about any of the side or angle measures, I cannot assume congruence. I don't want to make that assumption. Now, these two quadrilaterals in contrast have lots of markings. So let's see, can we match them to the corresponding parts? So I'm going to move or translate, I'm going to reflect, and then I'm going to do a rotation to see that yes, I have markings that match to their corresponding vertices. And that's how I want to name these shapes. So I start with one shape, in this case GHIJ, and I want to use those four letters to help me name the other shapes that is congruent. So G matched with K, H matched with L, I matched with M, and J matched with N. And I see they have the same markings, which is another way to recognize that congruence. Now, when we move to triangles, we actually need less information than having everything marked. We can use four different methods. The first one's called the side-side-side triangle congruence method. Here, if two triangles have all the sides from one marked as congruent to their corresponding triangle sides, then the two triangles are congruent to one another. So here we look at these two triangles. I have corresponding sides marked as congruent, so I can now assume they are congruent by side, side, side. But just to verify, I'm going to rotate and translate over to see, yes, the markings do match up, therefore I can see that these are congruent triangles. So I'll start with one triangle. In this case, I'm going to start with MPQ and then label it based on the corresponding vertices. M matched with R, P matched with S, and Q matched with T. So triangle MPQ is congruent to triangle RST by side, side, side. Another method is the side angle side method. Here we use the included angle of one triangle in two sides, and they have to be congruent to the corresponding sides and included angle of another triangle. So say I have these two triangles, UVW and ZAB, and I can see that they both have markings for sides and that included angle, the angle in between the two marked sides. That's the important. It has to be in between. So if I reflect it and then translate it over, I can see, yes, the markings for those three parts all match. So these triangles are congruent, but let's do that in an order that makes sense. So if I start with triangle ZAB, the corresponding vertice to Z was U, to A was V, and to W or to B was W. And those two triangles are congruent by side angle side. Now another method is called the angle side angle method. Here we have two angles and an included side of one triangle congruent to two angles in the included side of another triangle. That included side has to be in between the two marked angles. That's the important piece. So say we have our two triangles here. I can see I've got two angles marked in the included side. And if I translated it over, yes, they match up. So the markings help me see these two triangles are congruent. So if I started with triangle DEC, the corresponding vertices would be G, H, F, and they would be congruent by angle, side, angle. And our final method would be angle, angle, side. Here we have two angles and a non-included side of one triangle that are congruent to the non-included side in the two angles of another triangle. That makes them congruent. So it has to be non-included, not between in this case. So let's say I have these two triangles here. I can take one and I can rotate it and then translate it down and see, yes, the two corresponding angles match and the non-included side match. So they are congruent triangles. So if I start with triangle SRD and match them by angle, angle, side, that would go that F, and then it would go to L, and then to C by side, by angle, angle, side.